Welcome, ladies and gentlemen. Page 573 we were talking about adding and subtracting rational expressions. A little bit tricky, had a lot of different things to keep track of. And the first thing we have to do is find the LCD and check this out. This one, classic problem from the book. This denominator is off from this denominator by a sign. Here the 4 is positive, here it's negative, here the y is negative, there the y is positive. So if I factor out a negative, I will then get a positive y and a negative 4, which is then going to match that. And then I've got a couple choices with this minus sign. I typically will combine it with the other one and just switch whatever the middle sign was. I also technically could move it up to the numerator, but I will change these into plus plus is what I'll do. So now the LCD hopefully is a little obvious, is y minus 4. And I don't have to multiply either of those fractions by anything because they're not missing any components of the LCD. And then I can just combine them as y plus 3 over y minus 4. Yeah, so that's a classic book problem. The kind of problem that I always forget about is where it's off by a sign. So let's take a look at some other questions. What can I do for you?
Either 31 or 33.
All right, now we're getting more interesting. Ooh, 31. 3 of a kind. I like it. I like it a lot. So yeah, with 3 fractions, it'll be the same approach. I'm just going to factor all of the denominators, try to determine what the LCD is, and go from there. So let's see. So this first denominator, I believe, ends up being a pattern. That's x plus 1 all squared minus x plus 2. These denominators are not factorable. X plus 1 minus 3x over x plus 1. And so the LCD between all of these, does anyone have a guess?
X plus 1.
Well, x plus 1 would work for this one and this one, but then this one would have had an extra 1. So it's going to be x plus 1 all squared, so that way it could sufficiently have canceled with any of these if I was to divide by those. And I want to point out it is not x plus 1 to the 4th. That would be way more denominator than I need. All right. So now I'm going to go through and multiply each of these fractions by the part that it's missing. This guy is all set, right? He's got his denominator already. This one I'll multiply by x plus 1 over x plus 1. And this one I'll multiply by x plus 1 over x plus 1. Right. So I will have x over, well, I guess I can just write LCD here for the moment. Well, maybe it's saving like 3 symbols. It's not really that much help. Minus, and remember you have to FOIL these things, or distribute x squared plus 1x plus 2x is plus 3x. And then 2 times 1 is 2, all over the LCD. And then minus, and then distribute here, that would be 3x squared plus 3x, all over the LCD. And these minus signs, I'm going to have to distribute them to all of the numerator terms when I do that. So I will have x minus x squared minus 3x minus 2 minus 3x squared minus 3x all over the LCD. And now I think I've got some like terms I can combine. This guy and this guy. And I could combine, yeah, the 3x, and the positive x. Yeah, so we've got a little bit of simplifying to do. So I've got a total of negative 4x squareds, negative 7x, nope, negative 3x is negative 6, plus 1 would give me negative 5x, and then minus 2 all over the LCD. And now I need to check to see if this is factorable. I might steal a sign out of it just for, I think it's easier to work with trinomials when their leading coefficient is positive. And in order to check to see if that's factorable, what would I have to do? AC method, because, bless you, because there's a number in front of the squared term that is not 1. So 4 times 2 is 8. Factors of 8, 1 and 8, 2 and 4. And do any of those add to be 5? No. So it looks like my answer is likely just going to be this over x plus 1 all squared. And this minus sign you could move to the front here like that. You can move it down there and then get rid of the parentheses and stuff if you wanted. But let me just give this a quick check. Looks good to me. We got it right. So how about one more? One more for fun more. 27. Yeah. Oh. Let's see. I think I can fit one more on this side. So paste. And oh yeah, we've got a different schedule today, I imagine, don't we?
Probably the extended lunch schedule where you get out at 20 or something like that.
Let's see this denominator. Hopefully that sticks out to you like a sore thumb. Factors to be x plus 3, x minus 3. Difference of squares pattern. And then the LCD is going to be x plus 3, just one of them, and x minus 3. There we go. So it looks like I only have to multiply this one by x minus 3 over x minus 3. And I distribute properly, so that will be x squared minus 3x. So both of those are getting multiplied by x. The denominator is the LCD. Minus 6x over the LCD. There's really no concern about forgetting to distribute this minus sign here. It looks like this will be x squared minus 9x over the LCD. That looks different of squares-ish, doesn't it? But it won't be. The only thing I can do is GCF and x. Yoink yoink, as we say. So x times x minus 9 all over x plus 3, x minus 3. Box it. Nothing cancels out. That is quite all right. So, not too bad. No?
If, like, we had that problem, but we left it with x squared minus 9x,
Yeah, you'd have to... Well, we have to factor it to make sure that it can't simplify any further. So, yeah. So that's why we take it all the way. But, all right. Bye-bye, Internet friends.